Okay? Well, I've been comparing two different general approaches to the status of what is called the mental, which is just a descriptive category. To make it concrete, this would mean two different approaches to things like the creative aspect of language use, the problem of understanding Chinese, the formal relations on expressions, such as rhyme and entailment, problems of things like anaphoric dependency, how pronouns pick up what they refer to, which is a core part of what might be called the logical structure of language, and comparable phenomena in other domains of thought and the mental generally. So that's, when we talk about the mental, we're talking about those phenomena, that category of phenomena. One approach, and the one that I'm advocating, is the naturalistic approach, expressed, for example, by post-Newtonian scientists such as Priestley, who argued that these properties, whatever they are, these things are just properties of organized matter. So rhyme is a property of organized matter, like the property of attraction and repulsion, or electricity and magnetism. And if you believe that, your next task is to spell out the properties, to develop a theoretical account of the properties and the states and so on, and then to show how organized matter can have such properties. That's the unification problem. And if the history of science is any guide, that may very well require radical changes in the core parts of science. At least that's always been the case in the past. One naturally keeps an open mind. But in this case, the gap between the properties and what is known about the brain is so enormous that the idea that there might well be radical changes in the core sciences necessary is not at all surprising. Well, that's the naturalistic approach. We know how to proceed with it. You know, maybe it's hard, maybe it's easy, maybe you make a mistake, maybe not, but there's an intelligible research project and people pursue it in various domains. In contrast to this, there are various approaches that I've been calling non-naturalistic and dualistic, meaning, of course, not metaphysical dualism, but some kind of epistemological or methodological dualism. I discussed a number of such cases. A lot of them converge around Quine's radical translation paradigm. Yesterday, toward the end, we got into another one, what's called the computer model of the mind, which has the basic conception that the mental is the computational. So the mental properties are just software properties. A computer model of the mind could be completely naturalistic. That is, one could say among the properties of the brain are the properties of executing certain algorithms. That's a perfectly intelligible statement. The concepts are all clear, and we could proceed to investigate it. But the computer model of the mind crucially does not take that step. It insists on non-naturalism. I read some examples yesterday. It insists crucially on abstracting from biological structures in principle, not temporary abstractions because we don't know or because we're trying something exploratory, but abstractions in principle. Psychology, viewed in terms of this version of the computer model of the mind, is not a biological science. That's a crucial point. Second crucial point in the way this conception is formulated is that we're interested in automata that are in our computational image. That are enough like us, more or less. Okay, so our study is not a study of humans, but it's a study of a class of automata that are in the computational image of humans that are enough like us. And as far as I can see, as I mentioned yesterday, we could just as well study other classes of automata that aren't like humans and be just as legitimate. Since it's a non-physical science anyway, it's a non-biological science. Anyhow, let's keep to this. I quoted this picture from the encyclopedia, the recently published Encyclopedia of Cognitive Science. It happened to be an article by Ned Blocks. The same view is, with various modifications, is developed all over the place. Another good source is another philosopher, Justin Leiber, has a book called Invitation to Cognitive Science. He gives a similar picture. That book has the advantage of tracing things back to the first cognitive revolution. He knows the history and focuses much more clearly on Turing and the Turing test as is the normal procedure. And there's a lot of other stuff. This is, so that's the non-naturalist version of the computer model of the mind, to be distinguished from the naturalist version of the computer model of the mind. Okay. Now, the non-naturalist version of the computer model of the mind, the one that prevails in the field almost entirely, does raise a certain number of questions. So, for example, we have to ask, if we have something X, we have to ask, when is X a computer? Some object, mathematical or non-mathematical. When is it a computer? Well, of course, if this is just pure mathematics, we can stipulate. We can say it's a computer if I say it's a computer, But if this is supposed to be an empirical study, and apparently it is, because people who believe in it ask questions like, how can we empirically decide whether a strange organism is playing chess or understanding Chinese or something, getting quoted yesterday. If it's supposed to be an empirical subject, even though a non-biological subject, which is a curious idea to start with, but if that's what it's supposed to be, then the question, when is X a computer, is not easy to answer. That's a point that actually John Searle has emphasized correctly for many years. Under some interpretation, anything you like is a computer under some interpretation. And the things that are computers are not computers under other interpretations. And this is a general problem about artifacts, as I mentioned, which goes back to Aristotle. When an artifact is a such and such, a table, a desk, a key, a computer, or whatever, is a matter of the intentions, place in our space of human interests, and all sorts of other things. It's not part of its nature. Notice that that question does not arise in the naturalistic version of the computer model of the mind. The brain just is what it is. If one of its properties is being a computer, okay, fine, that's what it is. It's like having the property of attraction and repulsion. Another question that has to be asked is, given that something's a computer, how do we decide that Y is its program? In other words, in a computer, we make a distinction between hardware and software, but the distinction is not a physical distinction. It's a distinction based on our interests and concerns. Again, if it's pure mathematics, we have no problem, we stipulate. If it's a naturalistic version of the computer model of the mind, again, it's no problem. We don't stipulate, we just say it's true. Just as things have other properties, they have the property of executing certain algorithms. And that empirical claim, has to be evaluated by the usual criteria of scientific inquiry. Does it fit properly into an explanatory theory, so on and so forth. Okay? But in the computer model, in the non-naturalist computer model of the mind, this too is a problem. A third problem, which arises whether you regard this as pure mathematics or not, is what counts as in our computational image. What does it mean to be enough like us? Okay, obviously that has to be spelled out, whether you regard this as pure mathematics or an empirical study or whatever. And the usual answer to that, the overwhelmingly dominant answer to that, is passes the Turing test. Now, the Turing test, as I said, is not a specific criterion. It's just a range of possible experiments which you can set up one way or another, but it's a intelligible range of experiments, of criteria. And basically what this says is something is in our computational image if it passes certain performance criteria which would be indistinguishable from human performance by some measure or in some framework. That's the view that's essentially that is Turing's view with the modification that I mentioned last time. And the reason why Turing is commonly alleged to have started off the field of cognitive science with his 1950 paper in which this is proposed is that it is the standard answer to what it means to be in our computational image. So it's the answer that pretty much defines artificial intelligence, most of cognitive science, a wide range of philosophy of mind. And if you want to see a sense of how wide a range, take a look at the huge literature on Searle's Chinese room argument. Hundreds of papers and so on that. And look at the range of people who have tried to refute his argument, and they're all accepting the Turing test criterion implicitly. Nobody even talks about it because that's the way his problem's set up. You might have other criteria. So something about to be in our computational image means to be enough like us in some other way. Actually, nothing much changes if you add those things. Same kind of problems arise. So we can, for the purposes of discussion, keep to this one, which at least is loosely characterized by Turing. A number of people pointed out after class that there are all kind of ways in which you could, a judge could determine, could trip up the computer. And there are, but these are all discussed in the literature. Like, if the computer's answers come back if the answers come back too fast in one case, say for complex arithmetical computations, you're going to know it's a machine. So therefore, to pass the Turing test, you'd have to slow it down. Or if it, if it takes computations that require 100 years, it's a machine. So you therefore set it up so you don't, so it collapses if the computations become too long. There's a ton of literature on this, and we can put it aside. But just assume that various precautions have been taken to overcome the obvious ways of deciding whether something passes this criterion. That's not where the real problems arise. I mean, the problem doesn't arise in sharpening up the tests. You can always figure out ways to do that. The problem arises in why do it all together. That's a different question. And that doesn't matter how you fix up the tests. Now again, this third problem, which obviously has to be answered before the computational theory of mind has any content, doesn't arise in the naturalistic theory, computer model of the mind, because the brain just is what it is, period. We're not asking what's in the computational image of the brain, we're asking what the brain is. It's as if we're doing something like studying embryology, not asking about arbitrary, abstract systems which are similar enough to chicken embryos so that we study that class, not chicken embryos. We're just studying chicken embryos, period. So the question of what's in our computational image doesn't arise. And there are a bunch of other questions. So for example, what it means to say that we can empirically decide whether something is in our computational image, empirically decide, when this appears to be an abstract subject that's non-empirical. So in Hoagland's article that I mentioned yesterday, and in the answers to it and discussions and so on, it somehow assumed that the question of how to empirically decide whether something is playing chess or understanding Chinese is a meaningful question, and that's not obvious. And then there are other questions which one could raise. Well, let's assume that all those questions are answered somehow. That's a big assumption. I don't think they're very easy to answer without just stipulations. But let's say they're answered in some fashion, and incidentally, the question comment came up yesterday suggesting that if you pick the Turing machine criterion, as almost everyone does, for in our computational image, that's behaviorist. And that's not correct. It's not behaviorist. There's nothing in the Turing test that suggests any hint of behaviorism. Behaviorism is a set of ideas about how cognitive states or capacities or whatever develop. And different varieties of behaviorism have their own stipulations as to how that happens. conditioning or hidden variables or one thing or another. Associationism. I mean, each variety of behaviorism is defined by its a priori stipulations as to what modes of changing state are allowed to the organism. Okay? And then there are extreme versions of behaviorism, like, say, Skinner or Quine, which say you're not allowed to attribute any structure to the organism. Well, not quite no structure, but virtually none. In the case of Skinner, apparently none. There are others that are more lax on what you're allowed to attribute to the organism. But these are all theories of acquisition of dispositions or capacities or something or other. And there's nothing here about that. In fact, yeah.
You can call behavior what you want, but
yeah.
Many people consider that to define intelligence or to have mental properties in terms of passing the Turing test is behaviorism.
I agree. You can define behaviorism as you want, but what it's always meant until now is Skinner, Tolman, the whole history of modern psychology, which was a series of studies as to how capacities are acquired. If somebody wants to use it to mean something else, that's okay. The usual, I think it's just a confusion of behaviorism and operationalism. I mean, it's true that this is operationalist, but operationalism and behaviorism are two quite different things.
Usually it is said that Skinner, Watson behavior is methodological behavior. This is what...
That's not true. Skinner would certainly...
You can say what you want.
Look, Skinner does not describe himself as a methodological... I mean, Gilbert Ryle describes himself as a methodological behaviorist, not Skinner.
Usually Ryle's or Wittgenstein kind of behavior is called logical behavior. This is a doctrine about...
Okay.
Anyway.
But I don't want to argue about the terminology. There's a tradition of behaviorism which includes all of behaviorist psychology. You know, Hull, Skinner, Tolman, massive stuff. All of this, none of these people regard themselves as methodological anything. They are empirical scientists who are making assertions about how capacities and dispositions arise. Now, if philosophers want to impose some new set of terminology, okay. There's another movement, operationalism, which in fact goes back to late 19th century, Mach and people like that, and or instrumentalism, and that says that concepts are to be defined in terms of operational criteria. Well, of course, that's what the Turing test is. It's an operational criteria. But operationalism and behaviorism are conceptually two totally different things. In fact, the people who accept the computer model of the mind and the Turing test interpretation of computational image would hotly deny that they are behaviorists. This is cognitive science. It developed as an effort to break out of the behaviorist mold. Now, you know, if somebody wants to say, well, they're behaviors anyway, okay, but that's, you know, it's just using the term behaviorism in some other sense, which is quite divorced from the way the behaviorists use it, or the non-behaviorists, like these people. Anyhow, as long as we understand what we're talking about, it doesn't matter what terms we use. Okay.
I have a question about your second problem.
The software? Yeah.
Suppose that we have a program, let's say a Turing machine, and we have a physical machine. Do you deny that it is an objective question whether or not the physical machine, runs the program? Do you claim that it depends on the intentions of the builders?
Oh, sure, but everybody agrees with this. Kripke makes a big point about it in his book, for example.
Well,
Yeah, of course.
I'm asking about your...
Well, I think so. Well, I mean, if we add further assumptions, you know, if we add further assumptions, we can make a distinction, but we need further assumptions. Like if we make the assumption that putting a disk into the disk drive is a different kind of interference with the machine than, you know, changing around some of the internal circuitry. If we make that stipulation, then on the basis relative to that stipulation, we can distinguish hardware from software. But unless we make stipulations like that, we can't. I mean, if you look at the machine, it's just, everything's mixed up.
Could you go back to the way I put the question? We have the program and we have the machine.
But then you've answered the question already. So you've answered, if we've already picked the program and the machine, of course we can separate them, namely the way we picked them.
So in that case, an
No, it's not objective, it's stipulative. I mean, if I stipulate let's take the question, is being near Boston an objective property of things? Well, in general, no. On the other hand, if I define near Boston as within 100 miles of Boston, then I've stipulated it to be an objective property of things.
So I can stipulate that any machine is running any program. Is that what you are saying?
Well, if you look at a machine mathematically, that's true. It depends on what interpretation you give it. I mean,
I said you have the program and you have...
no, if you've answered the question in advance, then there's no longer any question because you've answered it in advance. I mean, it's the same as in any mathematical formulation of a Turing machine. If I say this over here is the program and this over here is the machine, then yeah, there's an answer to what's the program and what's the machine, namely what I said. I mean, it's like, suppose somebody asks, is being a theorem of a formal system an objective property as distinct from being an axiom, let's say? Well, no, of course not. Being a theorem is just being, a member of an infinite set. On the other hand, if I stipulate an axiom system, say I stipulate Peano's axioms, well, okay, once I've stipulated them, then I can say, yeah, that theorem over there is not an axiom, because I've stipulated the set of axioms. And if you stipulate answers, then the questions don't arise.
Let me see if I understand you. I think that given a program and given a physical machine, sometimes you can say that machine is running the program, and sometimes you can say, no, it's not running the program.
That's right.
I am asking.
Of course.
Any of these answers is objective?
No, well, they're objective relative to the initial stipulations. Just as the question whether, if I write out some formula of arithmetic, and somebody says, is it a non-axiom? Is it a theorem but a non-axiom? If I just ask it that way, there's no objective answer, because you can set up an axiom system any way you like. On the other hand, if I've picked an axiom system, say Peano's axiom, and then relative to that, yes, it's an objective question, but uninterestingly, because I've stipulated the answer.
So the answer is, difficult for me to understand.
Pardon? The answer is that...
Once we have fixed the program...
Yeah, then you can say what's...
Once we have fixed the program, then it's an objective question whether or not...
It's a trivial objective question. Once we've given the answer, it's an objective question as to whether that's the answer. Yeah, it is, because we gave it.
Trivial in what sense?
In the sense I just stated. Once you've given the answer, if I stipulate an answer, and somebody says, is it now an objective question whether that's the answer? Yes, it is an objective question because I stipulated.
Trivial in the sense that it does not require any empirical...
It requires no thought, once I've said that, it may require some computation, it may require a little computation, but if I've stipulated an axiom system, then relative to that stipulation, it's an objective question whether some expression is a theorem that's not in the axiom system. Yeah, that's objective but trivial.
I repeat, trivial in the sense that it does not require any empirical investigation?
None at all. No empirical investigation. It may require some computation, but you've given the answer in advance. Now, on the other hand, if you don't give the answer in advance, then all kind of questions arise. Actually, Kripke has why don't we just refer back to Kripke's discussion of this in his latest book on Wittgenstein, where he makes the point obvious to any mathematician that if you take a computer, or what's called a computer, you can look at it this way, you can look at it that way, it can be doing this, can be doing that, depends on how you interpret it. It's just a bunch of things turning around, You got to give it an interpretation before it even, it's a lot of electrical signals moving around, You've got to give it an interpretation before it becomes a computer, and you have to give it a further interpretation to distinguish software from hardware. Now, you can do that in all kind of ways, and sometimes they're rather natural ways. Like if you and I have a personal computer in front of us, we can make some very natural stipulations. I just mentioned one. One natural stipulation is that if you stick a hard disk into the disk drive, which changes the machine physically, that's a different kind of change than taking the machine apart and getting a screwdriver and, screwing around with the chips or something. We'll say that's a different kind of change, but only by stipulation. It's not an objective question whether that's a different kind of change. It is if we stipulate it. it's a natural decision to make, and we all make it. That's why we don't have any problem talking about hardware and software, but we have to understand that it is a stipulation. It's not an objective just as it's not an objective property of this entity that it's a desk, it's not an objective property of a object over there that it's a computer with this hardware. Those are matters of choice, intention, interpretation, and so on. That's the nature of artifacts, as has been pretty clear back to Aristotle. That's why we can't, as Kripke points out, there's a good discussion of it, you can't really say when a computer is malfunctioning objectively. I mean, if it's producing his crazy function, cost function, you don't know whether that's malfunction or function. It depends what people intended. Or to use another example of his, if you launch a ship, somebody builds a ship and you let it go down into the water and it sinks, you don't know if that's a malfunction or a proper function. Depends what it was designed to do. If it was designed to sink, okay, it worked fine. These are not objective questions short of stipulations. You can make various stipulations in which, relative to which, they then become objective questions. That's the general point. Now, let's imagine that all this stuff is worked out. Okay, so suppose somebody gives answers to these things, which I say is not so trivial, but let's grant it. Answers are given. Then we have, and I stress again that at least in the standard sense of it, there is a distinction, a traditional distinction between behaviorist and operationalist, and reliance on the Turing machine is operationalist, but the people would hotly deny, and correctly in the traditional sense, that it's behaviorist. They are cognitive scientists, not behaviorists. So suppose we work all this stuff out, then we have these two approaches, the naturalistic theory, which could be a computer model of the mind, just saying these are properties of cells, or it could be non-naturalistic, as in the mental equals the computational approach. And those two approaches are going to be quite different. Of course, we can't really state the differences until this one's worked out, until the gaps are filled, but we're granting now that they're filled. The approaches are very different. You can see it very simply. Suppose we have, say, two theories of rhyme, call them T1 and T2, or of anything else that falls within the mental. So let's say these are two theories of rhyme. And suppose we discover that in the case of human cells, the cells of the human body, our understanding of human cells is such that theory T1 is realizable in cells, and theory T2 is not realizable in cells. Okay, that's a possible thing to discover. Well, these two approaches would now differ entirely on what they conclude on the basis of such a discovery. The first one, T1, would say, okay, the naturalistic approach would say, in that case, pick T1 and reject T2, because we're trying to study humans. And if we had two accounts of the properties of humans, but only one of them is consistent with other accounts of the properties of humans. The second approach, the non-naturalistic one, in principle would reject that evidence, because it's a non-biological science. It doesn't matter whether the mental is represented in cells or, silicon chips or some unimaginable thing or whatever. So therefore, the fact that one of them is realizable in cells and the other isn't would just be irrelevant from the point of view of what's, the computer model of the mind as generally conceived. That's independent, incidentally, of whether you take the criterion of being like us to be the Turing test or you take something else. As I say, I'm going to stick to the Turing test version because that's the only one that's relatively clear, and that's the one almost anyone accepts anyway. But even if you kind of dress it up with other properties, all the same questions arise, so it doesn't really matter a lot. Well, anyhow, that doesn't say that the non-naturalistic approach is wrong. It just says the two are different, strikingly different. And this is going to show up all the time. I mean, if one theory, let's say, take the example of ERPs that I discussed yesterday, event-related potentials, electrical activity of the brain. If one theory of types of classifications of deviant utterances, this is pretty subtle already. If one theory of classification of deviant utterances, which breaks them into different types, correlates with ERPs, and another theory doesn't correlate with ERPs, and if, furthermore, we had a theory of electrical activity of the brain, so that these ERPs weren't just crazy numbers, but actually arose from something principled, in that case, the naturalist approach would select the theory that correlates with ERPs, and the non-naturalist approach wouldn't care. And the same is true about information from acquisition, or aphasia, or other languages, or whatever. And so across the board, there's going to be a sharp difference between the naturalist and the non-naturalist approaches. What kind of reaction should one have to this? I'll just repeat my own view. With regard to the naturalistic approach, in my opinion, it carries no burden of justification. If somebody wants to study the phenomena that fall under the mental, it's a bunch of phenomena, to study them the way everything else in the natural world is studied, no justification is required. That's self-justifying. Maybe one can argue this, but that's my assumption. So there is no burden of proof to be borne by the naturalistic approach. There are only questions of whether you're doing it right, or truth, or something or other. And then there's the standard methodological questions that arise throughout the natural sciences, but they don't bother us here. So the proper reaction to the naturalistic approach seems to me to be fine, proceed. What about the proper response to the non-naturalistic approach? Well, here there's a range of possible responses. Let's have a look at some of them. One response is the one given by advocates of the naturalistic approach. Now I'm talking about a reaction, an interpretation of the non-naturalistic approach, this one. Okay. Mental equals the computational, not biological, not a biological science. We're not interested especially in humans, but in things in the computational image of humans. A naturalist responding to this, that is a person who says we should study the mental the way we study everything else in the world. The naturalistic response to the non-naturalistic computer model of the mind is it's not worth looking at. So I don't care what happens to it. It's just not worth looking at. No argument has been given. It requires justification. Unlike the naturalistic approach, it carries a burden of justification. If you say I'm going to study some new problem in chemistry the way every other problem in chemistry is studied, you don't have any justification. But if you say, in this new area of chemistry, I'm not going to care about physical realization, then you have a burden of justification. Maybe you can meet it, maybe you can't, but you have the burden at least. So, but the burden of justification has not been given as far as I can see. So, for example, nobody's given a justification for the decision not to use information about cells to choose between T1 and T2, or not to use information about electrical activity of the brain to choose between two syntactic theories, or not to use evidence from child acquisition or whatever to choose between different theories of the mental. As far as I know, nobody's given a justification for that, or interestingly, even attempted to give a justification. I don't know if anyone's even attempted to give a justification. And there is a heavy burden of justification. Now, you can see the reason why people are led to the non-naturalistic approach. Here you have to speculate, of course. It's, again, exegesis. But it seems to me the reason, if you look back at the history of function, sometimes it's called functionalism or something else, you look back at the history, there was a feeling of uneasiness about the enormous gap between the phenomena that fell under the mental and what was known about the brain. There is an enormous gap. And to relieve that feeling of uneasiness, there are various attempts. I mentioned some of them yesterday. One approach was sort of functionalist. I may say, well, there's no big problem, it's software. So it's like robust things like computers. I think that's a mistake all along the line for reasons I mentioned. It's taking a manageable problem and trying to make it seem less mysterious by using an unmanageable analog with all kind of new questions that arise for artifacts but not natural things. So it's, as I said, frying pan into the fire in the English idiom, which somebody translated yesterday. But that's the only motivation I know. If there's any other justification, I haven't seen it in the literature. Now, from a naturalist point of view, there's a burden of justification that has to be given, It hasn't been given, it hasn't been attempted, so therefore forget it. No point looking at it any further. There's no, if any further problems arise in developing the non-naturalist approach, say these problems or other problems, say Searle's problem about the Chinese room or whatever, any such problems, the naturalist just doesn't care because it wasn't worth making the step in the first place. And any problems that arise in making that step could be of intellectual interest. You know, anything could be of intellectual interest, but it's of no empirical interest. It has no bearing on the world, you know, just like puzzle solving, which is sometimes interesting. Well, that's one kind of reaction. And I stress again that the naturalistic approach doesn't deny that the brain may be a computer executing software. Like, it accepts the possibility of, and in fact most versions accept the truth of, a computer model of the mind, but not this one. Not the one that is divorced in principle from biology, from the natural world, in other words, and that is studying things in our computational image, not us. Okay, that's the difference. Well, is there another approach to this? There is an approach which says it's just all meaningless. That's what I would take Wittgenstein to be saying. You know, Wittgenstein is subject to interpretation. I mean the late Wittgenstein. But when he talks a lot about these topics. I mean, not in these terms, but this kind of topic. And the point that he continually makes is that words like think, or you know, any of the terms that involve the mental, those are words of our language. And these words are just tools which are used the way they're used, period. There's nothing else to say about them. They're used the way they're used. The word think, he says, as a descriptive claim, which is accurate, I think. The word think is applied to persons. Persons think, okay? Just like birds fly, okay? The question whether something which is not a person thinks is as meaningless as the question whether something that's not a bird flies. He doesn't give that example, but the analogy would be the kind of things that came up in the discussion yesterday. If someone asks, is it an objective truth that airplanes fly? A Wittgensteinian would say, that's not a question. You know, the way the tool is used, birds fly, and maybe things enough like birds, but not machines. They don't fly. You can decide that they fly, or you can decide that they don't fly, but that's just changing the use of the tool, and you can do that if you want. And as I mentioned, languages have done it differently. Some liked the metaphor, and some didn't like the metaphor. You can say that a high jumper flies, or you can say that he doesn't fly, but that's just deciding to accept a certain metaphor. And that's a matter of decision, in a way. It's not a matter of fact. So the Wittgensteinian approach, what he says is, think is a term that applies to persons, or he says, kind of in passing, maybe dolls and spirits. You know, things that are enough like persons. That's sort of, and he's not going to require there to be any sharp criterion for that, of course, because this is just the way the tool is used, and the tool isn't used very precisely. Okay, so on those, but not machines. They don't think any more than they fly or swim or something like that. So the question whether a machine thinks is as meaningless as whether an airplane flies or a submarine swims. Okay. It does if you want to call it that. It doesn't if you don't want to call it that, but there's no question. So the issue is meaningless for Wittgensteinian. That's another approach. Notice that that's also a total rejection of the computational theory of mind, but on different grounds. It's not the naturalist. It's not inconsistent with the naturalist objection. In fact, in my view, both objections are correct, both the naturalistic one and the Wittgensteinian one, but they're different objections. And they both end up with saying, forget about it, it's not worth pursuing, it's not worth answering the questions. A third kind of approach is that it's meaningless, but important. And that's not as paradoxical as it sounds. That's Turing's approach, the founder of the field. Recall that what he says is, probably borrowing from Wittgenstein, who he was close to at that time, you know, attending his seminars and stuff. But he says he says the question whether machines think may be too meaningless to deserve discussion, but it's an important question. And he then proposes the Turing test as what's sometimes called a persuasive definition, an attempt to convince you to change your usage. Okay, he says, look, this is the way we ought to change our usage. So he said, we ought to change our usage so that we use the word think and, all the rest of the associated words in such a way as to accord with the Turing test. And then he predicts that by the, in another 50 years, this is 1950, so by the year 2000, he said, educated opinion will have sufficiently changed and usage will have sufficiently changed so that people will find no difficulty in speaking of machines thinking, although today, 1950, it's meaningless. It's like airplanes flying in 1900. So that's a view which says it's meaningless but important, and not a contradictory view. He's saying we ought to talk this way, not some other way. Okay, we'd be more clear-headed or something like that, which could be. There are all kind of criteria that could be used for how we ought to talk. So that's a third reaction. A fourth reaction is that it's exactly right. The computer model, the non-biological computer model of the mind, and if it's, that's almost everyone, at least who's interested in these questions. It's exactly right, and then we have to proceed to work out the problems. And then, so we get the kind of questions that, say, Hoagland raised. How do we empirically decide that a given strange object, usually a computer of some kind, is playing chess or understanding English? And his answer is, we, having accepted Turing's persuasive definition, he says the answer will be if it fools a skeptic, passes some version of the Turing test, and he then proceeds to give what he describes as an empirical argument that you can do it for playing chess, but you can't do it for understanding English, as an empirical fact. That's an empirical claim. Well, that's the path you pursue if you think that all this is exactly correct. Not only that, I mean the approach is. Let's make it very clear. The approach is correct. That is nothing by that. I want to distinguish two varieties of this: the approach being correct and telling the truth, or the approach being legitimate and being wrong. So, in fact, instead of correct, let me say legitimate. That is, it's a perfectly legitimate idea, And furthermore, for some people, true. It's empirical truth or something like that, that this is the approach to take, or some other form of rightness, what if empirical truth doesn't arise. These things are very hard to put sharply because this non-naturalistic approach is in some hazy area between mathematics and the empirical. So you don't know exactly at least I don't know when I read this stuff, what is meant when people say they're making empirical claims. It's hard to see how you can be making empirical claims in what amounts to a branch of mathematics, where you've sort of stipulated certain things and you don't care about the relation to the natural world. Anyhow, I'm allowing all of that, assuming all of that to have been settled somehow, sort of granting it to have been settled. Then you could assume that the approach is legitimate, the right kind of approach, that's the way we ought to proceed, and in fact, it's true. That's AI, most of cognitive science, most of the large parts of philosophy of mind, in fact, virtually everything that's even interested in the question, not everyone. So Hilary Putnam, for example, who was one of the originators of this point of view, has more recently rejected it totally, but over not on the grounds that I'm talking about, on different grounds, but quite a broad range. And of course, if I didn't mention it, AI, which is more or less defined by this. And then we've got to answer these empirical questions about playing chess and so on. Well, there's another possible approach, and that's John Searle's. And again, I'm not exactly certain that I understand exactly what he's saying. It doesn't seem entirely clear, but I think he's saying this. Yeah, it's appropriate and legitimate, but false. Okay, appropriate and legitimate, but just turns out to be false empirically. and he gives an argument that says it's false. He couldn't be giving an argument that says it's false, unless, if he thought it was meaningless, let's say. Then he wouldn't have bothered. If you take either of the first two views, you don't give any arguments, because it's not worth pursuing. So who cares? Unless you happen to be interested in the intellectual exercise. But as I read Searle's argument, the one I sort of briefly sketched yesterday about the Chinese room, that's had a huge impact on the field. There's an enormous literature trying to respond to it and deal with it and so on and so forth. It set off a major current in the field. And at least as I read those contributions, they all seem to be assuming that the approach is legitimate, makes sense to identify the mental with the computational, and then Searle says just wrong, and almost everybody else says right. And then the debate rages up and back, and they try to answer each other's arguments and so on. So Searle appears to be saying that the issue is the computational theory of the mind is legitimate, even important perhaps, but we empirically decide by an empirical argument that computers can't think, okay, that algorithms don't have mental properties. Okay. Notice that for Wittgensteinian, you don't empirically decide that. It's just a fact that algorithms don't think, because that's the way the tool is used. Similarly, brains don't think. Brains don't understand Chinese. Like I understand English, but my brain doesn't understand English. Although understanding English is what is going on in my brain. Okay. And the reason for that is that the locution, the phrase, understand English, is something that applies to persons, doesn't apply to brains. So therefore, though I understand English, and I'm doing it by virtue of my brain doing something or other, my brain doesn't understand English. And certainly whatever procedure my brain is carrying out doesn't understand English. It's not an empirical statement, it's just a comment on what words mean. Okay? But for Searle, it's an empirical statement. He thinks he's given a proof that he thinks brains do understand English, but algorithms don't. And let me repeat the argument, which had again an enormous effect. Searle just assumes the Turing test version of being in the same computational image. That's so common that that's fair enough. Wouldn't change much nothing would change if you added other properties, but let's look at that one. So his story is, you've got the Chinese room over here and John Searle inside it, and the questioner is feeding in questions in Chinese, and the interface is turning those Chinese, let's say they're typed in Chinese symbols or something, the interface is turning this, let's say, into a sequence of flashing lights or something, whatever the code is, any code you like. And John Searle is sitting inside there looking at the sequence of flashing lights. He's equipped, he wants to give a reductio argument. He says, suppose thinking is an algorithm. Suppose that understanding Chinese is, done by an algorithm. Let it be called algorithm A, okay? So that's the hypothesis, and he wants to reject it. He's giving a reductio argument. So he says, here's John Searle. He has in front of him the algorithm A. He has the capacity to understand its instructions. Like it says, move a symbol to the right. He knows how to move a symbol to the right. He has arbitrary amount of time and an arbitrary amount of paper and so on and so forth. This signal comes in. It's translated into flashing lights. The questioner was asking some question in Chinese, like, what's the weather outside or something. And he runs through the algorithm that, by hypothesis, understands Chinese. It says, push this button, and if something happens, push some other button. And he does all those things. And then, at the end, he types out something in some kind of code, and the interface interprets that something as an expression of Chinese. And the questioner out here says, yeah, that was the right kind of response. That was an appropriate response. So far you've passed the Turing test. And we're assuming here that you always pass, that you really pass it. For every question that comes in, you give an appropriate answer, as well as a human would do. Okay, in fact, indistinguishably from what a human would do. That's the hypothesis. But Searle argues he doesn't understand Chinese, and there hasn't been any understanding of Chinese going on. In fact, we could even make a stronger statement. Inside that room, he didn't even know that what was going on was translating Chinese. All he knew is there are buttons, lights flashing, and he was supposed to carry out some mechanical manipulations. In fact, putting John Searle in the room is basically only for dramatic effect. We could put in the room, say, a guy named Wang, who in fact does understand Chinese, and he could be doing the same thing, and there still would be no understanding Chinese going on, because Wang wouldn't have the foggiest idea that this input-output relation has anything to do with Chinese. All he's getting is lights flashing in front of him, and then he's doing certain mechanical instructions, and then pushing some buttons, and that's it. He didn't know any more than that. So the fact that he understands Chinese is irrelevant. There's still no understanding of Chinese going on. So Searle concludes that we've rejected the hypothesis. There can't be an algorithm for understanding Chinese. The brain can't be using an algorithm when it understands Chinese. Actually, we can simplify the story. We don't have to take something as exotic as understanding Chinese. I mean, the same issue arises if we take something quite simple. So let's say recognizing a straight line. Suppose somebody proposes that what the visual cortex does in identifying something as a straight line, not a curve, is to carry out a certain algorithm. Okay, there are such theories of visual perception. Then by the same argument, you can show there isn't. They were wrong. Theories were wrong. Because you could have Searle inside here, getting the coding of the straight line or the curve, which is some series of lights, and carrying out the algorithm and giving the proper answer, giving straight line if it was straight line, but not having the foggiest idea what he's doing. So there would be no seeing straight lines. And by the same argument, you would show that the brain doesn't carry out an algorithm to identify straight lines. In fact, you can push it to the point where it becomes close to paradoxical, though not entirely paradoxical, not a literal paradox. Searle, remember, he doesn't think this argument is strong enough to eliminate the possibility that people ever use algorithms. He thinks there's a well-defined class of cases where they do use algorithms, namely those where you have accessibility to consciousness. Okay, I talked about this last time. I don't think you can make any sense of that for the reasons I discussed, but let's grant it. So there's a class of cases where where people really are carrying out algorithms. That means the brain is really carrying out an algorithm, and that's where the person can introspect and say, yeah, that's what I'm doing. Okay, let's take such a case, let's say addition. Suppose people are carrying out a particular algorithm for addition, like, sometimes in elementary school when they teach kids how to add, they say if you have to add 7 plus 5, break up 5 into 2 parts, one of which will take 7 up to 10, and the other will be left, and then you get 12. Okay, like that's an algorithm for addition. And somebody could be taught that in elementary school, and they could actually be using it. That's the way they add 7 and 5. Okay, and they know they're doing it. They're right about their perception that they're doing it is correct. They're sort of running through that calculation in their heads. So let's take a case. Let's say John Searle is like that. So John Searle, let's say, uses, for example, this algorithm in addition. Now in this case, he agrees that there's an algorithm, and the brain is executing an algorithm. But notice this, by the same argument, that can't be right, because put John Searle in here and put in 7 plus 5 over here and code it into some set of flashing lights, and have John Searle carry, the algorithm isn't going to say what I just said. I said it intuitively, break 5 into 2 parts. The algorithm will say, push this button, and if something happens, push that button, and that kind of business. And he'll do all that stuff, executing the program. And at the end, he'll push a bunch of buttons, which are going to be read out here as 12 because of the interpretation procedure. So he will have added 7 plus 5, and he will, in fact, have used that algorithm, but he doesn't even know he's doing arithmetic. You know, all he knows is signals are coming in, and he's following some instructions, which look like just arbitrary sequences of things, and then he's typing out something which looks completely arbitrary. So by the same argument, we seem to have shown that his brain is not executing the algorithm that, in fact, he agrees it is executing. Now, this isn't quite a paradox, because you could reformulate it so that you get out of it, but we're pretty close. Well, Searle's conclusion from all of this is that we have to reject as false, right? Not as meaningless, but we have to reject as false the meaningful proposition that the mental is the computational, except in certain cases where you have access to consciousness. The argument, so the algorithm can't think, it's a non-trivial fact. That's why I had to give an argument for it. It's not a trivial fact, as it is for Wittgenstein, say, and for whom it's just like, you know, submarines can't swim. It's a trivial fact. He said, and then comes a huge debate. I mean, I want a huge debate about whether there's some way around Searle's argument. Curiously, nobody ever, in the whole debate, I don't think anybody ever studies the simple cases, like adding numbers or recognizing a straight line, though they raise all the same questions. So the whole discussion is about understanding Chinese, which is, you know, so far up in the air, you don't even know what you're talking about. Although there are very clear, simple examples that could be looked at that seem to raise the same issues. And, you know, some intriguing arguments come up. I mean, Searle's conclusion is that it's kind of like a naturalistic conclusion, but not quite. His conclusion is that since he thinks he's shown that except for the conscious cases, which do raise the problem I just mentioned, but that hasn't come up. So except for the conscious cases, he thinks has shown that the brain isn't executing algorithms. So crucially, for example, he would reject, and that's part of his main point, anything having to do with I language he wants to reject, because that would be executing algorithms, although in a naturalistic model. And he ends up with a position that a lot of people have been very unhappy with, in fact, almost everyone, that it's just some mysterious property of this messy object up here that it thinks. Well, that sounds like la maîtrise, but not quite, you know. He's saying that it's kind of like it's more like this old story about the brain secreting thought, you know. It's just something about biological mechanisms that gets them to think, but not execute algorithms. That they're not allowed to do. The question arises. Then, of course, the naturalist will ask, well, why not have that property? And, you know, there's no answer to that. The arguments are sophisticated and complex. I mean, if you're interested, you can look at the literature. I don't see much. So, for example, one philosopher, Steve Stitch, has argued that something's got to be wrong with Searle's approach, because if you take the brain of somebody who's, let's say, understanding Chinese, or for that matter, adding numbers, and since, according to Searle, this is just a matter of, you know, kind of like a mystical property of cells. Suppose we take one cell, that we take, say, some person who is thinking, you know, and we change one cell in the brain, and we replace it by a chip, silicon chip, which has exactly the properties of that cell. Okay, is he still thinking? Well, you get onto a slippery slope argument. Presumably he's still thinking if you change one cell. I suppose you've changed n cells, and he's still thinking. Is that next cell going to make him stop thinking? You know, well, obviously, if there's no point at which he stops thinking, you're going to end up with silicon chips, a computer, in other words. But it's doing the same thing all the way along. So, you know, it's got to be something wrong with it. There's that kind of argument. And then Searle has his answers to those. And so it goes up and back. I'm not going to say anything about it because, in my opinion, it's not worth running through the debate. It's kind of amusing, you know, like a lot of things are amusing, but it's beside the point. It's beside the point because the questions weren't meaningful in the first place. They weren't meaningful for Wittgenstein's reasons, and they're not worth looking at for naturalistic reasons. That's two different things. Okay? And if that's correct, it doesn't matter much what happened in the debate. And it doesn't matter whether what I just mentioned is a real paradox or only close to a paradox. In fact, nothing matters because it wasn't worth looking at. It's about on a par with the debate, 90 years ago as to whether airplanes can fly. If somebody might have come along and said, well, yes, if they're enough in the mechanical image of eagles, and then propose the equivalent of the Turing test, say, well, if they can fool people into thinking they're eagles or something, it wouldn't be a sensible discussion. And as far as I can see, this is no more sensible. I think the reason it's pursued is another example of the temptations of non-naturalism and the reasons for resisting those temptations. If we simply resist them, questions don't arise. And I think we should resist them, and I don't think there are any fundamental problems if we resist them. If we simply go back to the naturalistic approach to mind, and we tentatively propose, maybe correctly or maybe wrongly, that there's a computer model of the mind, namely part of the architecture and structure of the brain is in fact a computer which in fact is executing such and such algorithms in some cases, these being factual statements about the brain on a par with other factual claims about properties of physical objects. We then investigate them by the normal methods of science. No special conceptual problems arise. And that's it. None of these questions come up. And we don't seem to have missed anything. And we have no burden of proof to bear. And we can, if we like, appeal further to the Wittgensteinian argument that there doesn't even seem to be anything that you're talking about. Well, that's my opinion about cognitive science. And again, remember, I'm talking about the reflective parts of it, not the parts where somebody works out the algorithm for recognizing a straight line. That's fine. Nothing wrong with that. Although, as I mentioned before, cognitive scientists are often schizophrenic about this issue. I think much in the way that physicists were schizophrenic about the molecular theory of matter 100 years ago. The methodological side of their brain says we can't do what we're doing. And the scientific side of their brain says I'm going to do it anyway. You very commonly find that. Well, superficially at least, the departure from naturalism in the contemporary cognitive sciences is kind of reminiscent of the Cartesian tests for the existence of other minds. So, for example, if you go back to the Cartesian era, say 18th, 17th century, there were people called minor Cartesians, like people who tried to carry out the Cartesian program but didn't make a huge impact. People like Coeur-de-Moi, for example, was maybe the best. They tried to carry out the Cartesian program. And he set up elaborate experimental tests. I mean, these aren't real experiments. In those days, everything was a thought experiment, including probably what Galileo was doing, I mean, you sort of described what would happen, and you wrote something about it, and so on. So these are experiments, but, experiments that could be carried out, turn out a certain way. Coeur-de-Moi designs a whole raft of experiments, which would be used to determine, as he puts it, whether another creature that looks like me has a mind like mine. Crucially, that looks like me, because he's tacitly assuming the Wittgensteinian test without the sophistication that goes behind it. Saying, look, if it doesn't look like me, the question doesn't even arise. I mean, if it doesn't have a face, then the question of its having a mind doesn't arise. So, because we're just talking about terms that are used in a certain way. He doesn't say any of this, but I assume that that's what lies behind looks like me. In any event, he gives a whole series of remember, the task was this. I know that I have a mind, because of the Cartesian arguments, and the problem is the problem that's called the problem of other minds. It wasn't called that in those days, but later became called that. The problem of other minds. How do we know anything else has a mind? How do I know you have a mind, but the table doesn't, let's say? Since I can't introspect about you, I can introspect about me, so you have to set up tests, and he sets up a battery of tests, and then he says, if this other creature passed all of these tests, it would only be reasonable to assume that it has a mind like mine. Okay, that's the argument. Well, that sounds like the Turing test, but it's not. The reason it's not is because it's entirely naturalistic. his tests are like litmus tests for acidity. You know, they're tests to determine whether some object has some real property. Remember, the science that he had behind him, which was wrong science, but science, is that there is a property, being a mind, okay, which is rooted in a particular substance. And some things have it and some things don't. And he wanted a bunch of tests to determine whether something has it. So it's kind of on a par with the litmus test for acidity or anything like that. That's completely naturalistic. Wrong-headed, as we know, but naturalistic. That's not true of this approach, where everything is crucially non-naturalistic and insists upon it. Okay? So though the tests sound similar, they're different. They're radically different conceptually. The same is true of simulation. Actually, there's quite an interesting paper on this by John Marshall. He's a British psychologist who's also been interested in the history of these topics. And he has a paper that came out in some Festschrift a little while back. I could look up the reference if you're interested, in which he does something I'd never seen before. He goes through, see, in the 17th and 18th century, it's well known that people were completely, utterly fascinated by automata. I mean, they had these guys creating very complex automata that, were doing all sorts of crazy things. I mean, and that naturally raised the question whether people are just automata. Just as today with computers, it raises the same question. So he goes through the whole record. I mean, the most famous of these guys was somebody named Jacques de Vaucanson, who was, building automata that were just the marvel of Europe. I mean, they were automata that seemed to do all kinds of things. He goes through the background, and it turns out, I think he shows quite convincingly, that these people, like Vaucanson, were trying to carry out simulation in the modern scientific sense, not the computer science sense. They were, like Vaucanson, one of his examples, which I think I mentioned before, was a duck digesting food. And he tried to model the process of a duck digesting food in an automaton. And it was so realistic, everybody was, amazed and so on and so forth. But crucially, he was not trying to say that the duck is digesting food. He wasn't giving a criterion. He wasn't concerned with any criterion, operationalist or whatever, to say that digesting of food is... he wasn't... Think what he could have been doing if he'd been doing the analog of the computer model of the mind. He could have said, look, I'm interested in digestion of food by ducks as a non-biological subject. I abstract away in principle from ducks, okay? I'm just interested in digestion of food by ducks abstractly conceived. I want to consider all things in the mechanical image of a duck, okay? And I'll say they're digesting food, all of those things are digesting food if some criterion is satisfied. Say, an analog to the Turing test. They fool people into thinking they're ducks or something, or some other criterion, okay? That would be an analog to the contemporary cognitive science, contemporary philosophy of mind, but he didn't do that. In fact, he purposely made the duck transparent so that people could see that it's not a duck. He wanted them to be able to see it. And he also wanted them to be able to see what was going on in his model. And in fact, what he was doing was constructing a model very much in the manner of the natural sciences, normal manner. Here's a model, by looking at it, certainly it abstracts away from some properties of ducks, like it doesn't have feathers and so on. So here's a model which he thinks gets down to the core of what digestion is, and he's going to demonstrate these core properties by having you look at the model. Thank you. Well, that's simulation in the sense in which it's done in the natural sciences. And it's very different from the kind of simulation, if you like, that's done in, say, chess-playing programs, the Drosophila of the cognitive sciences, as Herb Simon put it, where the trick is basically to achieve some criterion, and maybe the usual case, to fool people into thinking you're a person. That's a completely different form of simulation. For the 17th and 18th century people, the chess-playing programs would have been of no interest whatsoever, because they're teaching you nothing about how people think, zero. They're designed on different principles. So therefore, they're of absolutely no interest. They would have taken exactly the view that I think everybody ought to take to the chess playing programs today. Certainly any natural scientist should and would. They're just a waste of time. They're not teaching you anything about people in principle, or about anything else in the natural world in principle. Rather, Wittgenstein and others were interested in simulation in the way it's done all the time in the natural sciences. That's what I call contingent abstraction or exploratory abstraction. You know, you throw away some properties, you look at other properties, because you figure that way you can learn something about the real object. So that's like the computer model of the mind taken naturalistically. In my opinion, there's been a very serious regression since the 17th century in this regard. The cognitive sciences picked up again many old topics that had been forgotten, and that was good. But in my opinion, they're approaching them much more irrationally than they were approached in the 17th and 18th century. And this is a good example. This comparison strikes me as a good example. Well, to go on to another 10 minutes or so. Yeah. Let me just raise another issue this is about all I have to say about cognitive sciences and AI and so on. I mean, I just think it's off the wall. I don't think there's anything to say about it. There are a number of issues that this model, the computer model, is so completely taken for granted in the philosophical literature that it's led to very serious misunderstandings about what other people are doing, because it appears to be almost inconceivable in the literature that anybody could be taking a naturalistic approach. So what you get is efforts to interpret work like mine, for example, which takes a naturalistic approach to the mind, and then people get really confused and they see huge paradoxes because they take it for granted I must be talking about the computer model of the mind in this sense, because that's the only possible idea that one could have. You can get there's some good examples of this in various publications by two philosophers named Michael Devitt and Kim Sterelny, who've written a lot about these topics, both separately and together, books, articles, and so on. They raised the following question, actually. I'm the target in this case. They developed the concept competence in English. Okay. Competence in English is explained in terms of the computer model of the mind, like a Martian with silicon chips could have competence in English. And then they say they find it bewildering that linguists, meaning me, should confuse a theory of I language with a theory of competence that includes Martians competent in English as well as humans. And they take it for granted that that's what we must be studying. We must be studying a notion of competence which is not parochial. It doesn't deal just with humans. It deals with anything in the computational image of humans, and it's non-biological. And since that's what we must be studying, competence in English must be that. And the Martians have competence in English, and plainly a theory of I language isn't about that, because maybe the Martian is doing it some totally different way, not in terms of the principles of universal grammar. Universal grammar, I mean, like my theory of rhyme, let's say, T1, or some theory of, sentence structure or semantics or whatever, is a very parochial theory purposely. That is, it's supposed to be a theory about humans and their organization. And there's no meaning to the question, what is it? Competence in English is just defined as the property of having a certain state of the language faculty, which is this I language. Range of I languages, because English isn't a thing, of course. It's an indeterminate collection of things. But if you pick one of them, having a particular I language is having competence in that system. That's what it means in linguistics. But that seems to them an unintelligible notion. And they therefore, as I said, find it bewildering that people should give a theory of I language and confuse it with the topic of inquiry, namely competence being something that includes Martians. Well, I also find it bewildering. I mean, I would find it bewildering to confuse, I'm the target, I'd find it bewildering to confuse a theory of I language with a theory of competence in their sense. And the reason is I find it even more bewildering to imagine what a theory of competence is in that sense. What's a theory of competence in English that includes Martians who do it by some method other than I language? I have the foggiest idea what that means. It seems to me a totally bewildering idea. It's like a theory of digestion that doesn't just deal with ducks and people and so on, but with arbitrary creatures, you know, who are like ducks by some criterion we set up. Now, it's totally bewildering, I agree, as any non-naturalist approach is. But there's nothing bewildering about talking about a theory of I language. There would be something bewildering about extending it to a theory of competence in the sense that they take for granted, but seems to me unintelligible. Well, that's the standard line of debate that goes on in the philosophical literature. There's just like an impasse. People aren't even talking to each other because of this sharp break over the legitimacy or the meaningfulness of the non-naturalistic, dualistic approach to mind that's developed through functionalism and into the computer model of mind and so on. Okay, why don't I stop it at that point and pick it up next time, shall we?
I have several questions. First, I think that there must be some basic misunderstanding in my question before, because I find your answer obviously false, and many people here and you yourself find it obviously true. So to try to solve the misunderstanding, let me give you my reasons.
What are we talking about?
About your second criticism, the question of software. Yeah. Okay.
How do we decide whether a computer, an object, is running a particular piece of software?
Let me give you my reasons. Suppose that someone comes here from a trip from Mars, for instance, with an object. The object has keys and a screen, and we have the object here on the table, and then someone comes along and claims that this object realizes a particular program. Here is the program, Turing machine, for instance. Then I would say that there is an objective question, independent of the intentions, if there were any builder of this object, independent completely of the intentions of these alleged builders, whether or not this thing realized this program. And I would say that...
thing is a computer or what?
No, we don't know what. It's an object with
grains of sand on the beach.
Yeah, it could be a table.
There's a bunch of grains of sand on the beach, and we're trying to decide whether it realizes a particular program.
Yeah. So I would say that to answer this question requires investigation, empirical investigation, and perhaps not trivial empirical investigation. First, we should see, suppose that the program is an addition program. First, we should see if it gives the right outputs for the given inputs. But this is not enough, because the program also stipulates how the outputs are obtained. The program typically involves representations, states. Then to answer the question, we should look for physical states of the thing, identify these physical states with the representations, with the states postulating the program, and then we must see that the thing works as the program says. All of this requires, obviously, to me, empirical investigation, and perhaps not trivial investigation, and perhaps we are not going to be able to answer the question just for empirical reasons. So it's obvious to me that your answer was false.
Well, it's obvious to me that your proposal is false, so we must be disagreeing somewhere. Turing machines are mathematical objects, okay? They're just doing whatever they do. They're just grinding away. We don't know that they're computing. We don't know that they're computing addition, any more than we know that, say, Peano's axioms. There's no objective sense to the Peano's axioms plus the rules of inference are a Turing machine.
Yeah, Turing machines
are generating theorems. But when we say that Peano's axioms plus the rules of inference are generating theorems of arithmetic, that is not an objective fact. There is no empirical inquiry that can...
I agree completely.
Okay, fine. But that's exactly what Turing machines are like. If I if I go to some other planet, let's say, other universe, and I find a beach with lots of grains of sand organized in a particular fashion, it could be the case, that the way those guys over there interpret things, the organization of grains of sand on the beach is an input, is a program, a piece of software, which is an input to a mountain of a particular shape, and under some rule of interpretation, when you pick some pieces out of the set of grains of sand, you're giving a particular input to the mountain, and its shape, under a rule of interpretation that you give, it's adding the numbers and getting an answer. And it could be that that interpretation will in fact calculate addition. Well, okay, so the grains of sand in the shape of the mountain are a computer, and you can do it for anything. On the other hand, if some Martian type comes down here and looks at my PC, and he knows all about arithmetic, my personal computer, he knows all about arithmetic, and he looks at this, but he never saw a personal computer before. All he sees is you push certain buttons, you push certain keys, you stick a thing in the side where there's a disk drive, and then he could look inside and see all kind of whirring of, chips doing this and that, and electrical signals and so on, and out comes some signal, actually an electrical signal of some kind. And he wouldn't have the slightest reason to believe that that's adding. It only becomes adding if we impose an interpretation which says that the key that has this on it is associated with the number 1, and the key that has this on it is associated with the number 7. And when the screen reads, when the electron beam that is shooting across the screen gives something which to me, maybe not to him, but to me visually looks like this. After all, it's just an electron beam going across the screen, finding gaps and so on. Maybe he has a different visual system, and he actually sees the electron beam shooting across there. I see 12, but that's just because my perceptual apparatus is keyed to the electronics of this thing in such a way that I get those symbols out of it. They're not really there, of course. They're just my visual interpretation of some sequence of electron beams passing across the screen. He might pull out some other thing from it and get some whatever it is. He would have no reason to think that that's 12 any more than he would have any reason to think that this was 5 plus 7. So he'd have no objective way to find out that the computer is carrying out an addition program. And the same is true generally. Anything could, as Kripke and Searle and others have pointed out, anything could be a computer. Whether something's a computer carrying out a certain program is a matter of interpretation of a physical mechanism. So that's why problems arise in the case of artifacts that don't arise in the case of real objects. In the case of an artifact, you don't know what it is on the basis of its physical constitution. You only determine what it is on the basis of its place in some very, usually quite complex space of human interests and intentions and purposes and so on. That tells you what it is. That's a problem that doesn't arise in the case of, say, nematodes or brains. Now, I think if, we're each thinking that what we're saying is trivial, so we're probably misunderstanding each other.
It would be easier if you answer my question exactly and not...
I didn't. I thought I answered it. I mean, I said that...
I don't claim that any question just about the program is empirical. Questions about the program are mathematical questions. I don't claim that they are empirical. I claim that the question whether or not a given thing
is computing the program.
Is implementing a given program is an empirical question.
But let me give you...
Excuse me, I have given an argument.
What is the argument? I didn't hear any argument.
I have given a reason. I have explained why we investigate, why it would take empirical research to answer that question.
You're just repeating your proposal. That's not an argument.
Could you say exactly where I was mistaken?
You didn't give an argument, so it wasn't mistaken. You just made an assertion. Assertion, it's an assertion that this is an empirical issue, and I don't see why it is an empirical issue. So let's make it concrete. Let's take this other universe where they have these grains of sand and a mountain of a certain shape, and the people there, they interpret grains of sand and shapes of mountains as a computer. Okay, is it an empirical question whether that is a computer? If it is, how come a set of grains of sand and a mountain in our place isn't a computer? Well, we know that this can be interpreted as a computer, computing the plus function, let's say. I mean, everybody knows that, right? It's obvious. There's a mode of interpretation of the grains of sand. We'll have more and more. We'll have to allow infinitely many grains of sand and the usual idealizations. But the grains of sand plus the shape of the mountain could be a computer, and in fact are under a certain interpretation. Is it an empirical issue whether if I go to the beach in Girona or wherever it is and look at a pile of sand and I see a mountain in the background, is it an empirical question whether that's a computer? Well, I don't think so. It's a question of decision.
Could you give an interpretation under which you sit on is running WordPerfect?
Yeah, it's easy. I mean, it's just different orientations of the chair can be interpreted mathematically as associated with certain numbers and so on and so forth. I mean, it's just a question of, look, everybody knows how to do it in principle. It's just a problem of imagination to do it in a particular case.
I see your point now. Okay.
Yeah.
I have some different questions. About the Chinese room...
Yeah. Could we hold off for a second and pick up another topic and then come back? Yeah. Sorry.
This discussion reminds me another discussion about the neo-positivistic view of science. For the neo-positivist people, the science, the theories, were just a formal system. And in a formal system, theorem proof was just a sequence of steps in an algorithmic system prepared previously. And also a definition was a short writing, nothing else than that, just a short writing of a sequence of things. Okay, that was a mathematical point of view developed into a philosophy, and also were the mathematicians who didn't agree with that, because Lakatos pointed out that with this philosophy we cannot think at all. And thinking in mathematics is not to develop in algorithmic system. You have to think in another way. So he put in this book, Proof and Refutations, the idea that also working into a formal system had a lot of empirical work, a lot of empirical work to do, just changing definitions, proving theorems. It's something outside the formal system.
Something outside, but is it empirical?
Yeah.
It's certainly something outside the formal system.
Yes.
It's like it's an imaginative act or a creative act or something.
Yes.
Yeah.
Yeah.
Yeah, but look, even the strictest formalists, say Hilbert, didn't think that this formalism was capturing mathematical reasoning.
Yeah.
I mean, but certainly it doesn't. Yeah.
So no, I mean that also the mathematicians were very glad, saying that we are not related to properties of the world, we just think in mathematics, were able to discover that a formal system is not sufficient to explain thinking and mathematical thinking.
Well, it's even more than that. A formal system isn't enough to explain arithmetic, because you don't know whether a formal system is arithmetic unless you interpret it that way.
Yeah.
And in fact, as we now know, even in the case of arithmetic, no formal system can capture our intuitive model of it. You always get non-standard models.
Yeah.
So you can't even capture. We know it's even known that there is no mode of interpretation which will guarantee that any formal system for arithmetic will give you arithmetic.
Yeah.
You can't even do that.
So what surprised me is that mathematicians that do not agree that the thinking can be reduced to a formal system and the working in an algorithmic way in a formal system, maybe they defend that intelligence is, can be reduced just to an algorithmic way.
Yeah, I don't know. I find it awfully hard to believe that Turing, who was a good mathematician, could have believed that. Turing certainly knew that creative mathematical thinking is not following out a formal system. He might have believed, and probably did believe, that there is some algorithm, not the formal system, but some other algorithm that captures what Turing does when he makes a mathematical discovery. That's consistent, but it surely wouldn't have been running through a formal system. I mean, I say even the sternest formalists, say David Hilbert or somebody, didn't ever think that running through a formal system was proving anything. You run through a formal system, you get junk. If you want to prove something, you have to have an insight. You have to have an insight into truth. And then you try to sort of make up some justification for it. And surely any working mathematician knew that. In fact, I think it came up yesterday or something, in the history of mathematics, most of the great work was done before anybody even knew what a formal proof was. I mean, until the late 19th century, there was no notion of proof. In fact, I think until Hilbert's formalization of geometry, which was like, about 1870 or something, there really wasn't any notion of proof. But people were proving things all the time, even without a notion of proof. And probably what they were doing, nobody knows what they're doing. I mean, Adamar has this book on, mathematical creation, in which he sort of asked people, and he's an important mathematician himself, but he asked a lot of people how they do it, and it's just totally mystical. I mean, people get insights. I mean, they go to sleep and they wake up and something's in their head, and you probably are using physical intuition. I mean, an abstract topologist, in his study will tell you he doesn't use any physical intuitions. But, you look at him in the evening when he's working on this stuff, chances are very strong he's got some physical model in mind, and is trying to play with it and do this and that to it. So there are all kinds, and in fact, for a long period, probably up through the 19th century, good part of mathematics just was the exploration of basically two intuitions, our intuitions about physical space and our intuitions of number. Almost everything was some playing out of this. The Bourbaki school, in their introductory volume on history of mathematics, make a big point of this. That in fact that's all mathematics. Well, they think it's all it ever ought to be, but they very anti-formalist. But their view was that up until the 19th century, when you get this formalism, that's all it was. People were just exploring their intuition of number and exploring their intuitions of space, or maybe higher order space, and so on. And they're doing it somehow, but nobody knows how they're doing it. And when they're finished, they want to get a coherent story, so they give something they call a proof, which is supposed to convince other people that things are this way. But surely running through a formal system can't have anything to do with mathematical creativity. I think that even, whether you're Bourbaki or a formalist, everybody would agree on that. Were you going to say something about Chinese rooms when I asked? Oh. Yeah.
Suppose that we have the correct theory of language I of some Chinese speaker. Suppose that we put this theory in the form of a computer program. And suppose that the program that cell is running inside the Chinese box is this program.
Yeah.
Would you say of the whole system, of course cells does not understand a word of Chinese, but would you say of the whole system composed of the program and cell that it understands Chinese?
I wouldn't, because I regard...
What is the reason for that?
Yeah, I accept the Wittgensteinian point. The phrase understanding Chinese is a phrase of natural language. And phrases of natural language mean what they mean, not what somebody decides to make them mean. It's an objective fact that the phrases of natural language mean what they mean. And understanding Chinese is something that people do, okay? Just like flying is something that birds do. That's just the way the tools are used. So the question whether the program is understanding Chinese is pointless. In fact, I'll give an even simpler case. Suppose we take Wang, who understands Chinese. Now we look inside his brain and we see the language faculty, and suppose we give a description of what it's doing when he understands a sentence. And then I ask, is Wang's brain understanding Chinese? Answer, of course not, because understanding Chinese is not a property of brains. It's a property of people.
If the system were a nice robot like this in Blade Runner with human appearance, although...
A human appearance?
Yeah, but it's a robot. I mean, it's not biological.
Then would it be understanding Chinese?
Well,
you know, look, you can be fooled. I mean, you can imagine people... The answer is the question would be meaningless. Or rather, see, I think Wittgenstein is exactly right. Notice what he says correctly, I think. I mean, I think he's giving a correct description of language. He's saying words like, he says think, but, you know, we can use any word involving the mental sphere. Think and other such words apply to persons or dolls or spirits, meaning there's some, you know, penumbra, some range around it which isn't very definite. I mean, the words of natural language always have what is called in the philosophical literature open texture. They're not well defined. You know, none of the words of natural language are well defined. They pick out something in a semantic region, but they're quite indeterminate about how far you go. That's why you can, you know, it's never very clear whether you're using a term metaphorically. I mean, we constantly are using terms in new situations. If it's sort of far enough from the usual usage, we call it metaphor, but that's kind of like a vague thing. And whether we would decide, you know, that something that's enough like a human, like a person, is understanding Chinese, it's like, you know, deciding whether something that's enough like a bird is flying. I mean, like, you know, for example, the question whether, you know, a Boeing 707 is flying is arbitrary. But there's a new kind of airplane coming along, which has, I forget what it's called, but the wings are not rigidly attached to the fuselage. Okay, the wings move up and down independently of the fuselage. And the point of it is that it gives you a much smoother ride, because if there's wind turbulence, the wings will move, but the fuselage will stay steady. Okay, that's more like a bird, right? Now we got something more like a bird, like an eagle doesn't go up and down like this every time the wind shifts, because he stays stable, because his wings go up and down like this. Okay, now we've got a machine a little more like an eagle. I mean, is it now flying? Well, you know, these aren't serious questions. You know, at some point we may decide it's flying, at some point not. But it's not a serious question. It's not the kind of question you want to give an answer to.
I see your reason, too.
Yeah.
The last question. Today you have been, in discussing the computational model of the mind, you have been emphasizing the biological. But 2 days ago, in discussing Searle's own view, Searle's view that the mental is the neurological or the biological at a higher level.
Not the biological, the neurophysiological. Well, there's a big difference. There's a crucial, remember, I'm taking...
Yeah, my question was, could you remind me your reasons against Searle?
Okay. Remember, there was a phrase, which in fact I took from Searle, but it's very common. The phrase is, this says the mental is the computational. I've been talking about that. There's another one which says the mental is the neurophysiological. At a higher level. There's a third position. So the mental is the computational is one position. The mental is the neurophysiological is another position. And a third position, the one I'm advocating, is the mental, meaning, you know, all the properties that we put under this descriptive category is properties of matter. Probably cells, though we don't know for sure. Probably cells. But that's an empirical speculation, a plausible empirical speculation. Well, this one here, the mental is neurophysiological at a higher level, is a much further speculation. You know, because the neurophysiological is only a piece of the brain. I mean, and if by neurophysiological you mean, say, synaptic connections among neurons, it's even a smaller piece of the brain. And to say that that piece of the brain is what's carrying out and neurophysiology is a particular way of looking at that piece of the brain. There might be other ways of looking at neurons. Like I gave an example, I don't know if you were here at the time, of the study of nematodes, which are these, were you here when I talked about this? These are little worms. This is the most complex physical object that's completely understood in terms of developmental pattern and wiring diagram. They have 300 neurons. The wiring diagram's completely known, and the developmental pattern's completely known, so they're an interesting object of study. Nothing is understood about what they do. The study that I referred to tried what amount to neurophysiological models, if by that one means looking at synaptic connections among neurons. Tried first connections models, just threw them out because they were hopelessly inadequate. Then it tried what, you know, it's a little clear what we mean by neurophysiological, but if we mean what neurophysiologists study, like synaptic connections, it tried that. That didn't work. He then made up much more complex models involving all sorts of other kinds of chemical interactions and this and that, you know, asynchronous computers, I mean, all kinds of crazy models. And with all that stuff was able to come a little closer to characterizing what a nematode does. Well, okay, he abandoned the neurophysiological. That is, you know, we don't talk about the mental in the case of nematodes, but say turning, you know, moving in that direction was not the neurophysiological at a higher level, because the neurophysiological was just the wrong thing to look at. Now, in the case of thinking, it might turn out that the neurophysiological is the relevant level, or it might not. That's an empirical claim based on nothing, except the fact that neurons are there. And you don't make empirical claims on the basis of that sort of thing. I mean, if somebody came along and said, the mental is the vascular at a higher level, vascular meaning referring to blood flow, if somebody said the mental is of the vascular at a higher level, you know, everybody would laugh. I mean, the fact of the matter is there's a ton of blood flowing through the brain. Huge quantities of blood go through the brain. Nobody knows what it's for. And so, okay, suppose somebody comes along and says, I think the mental is the vascular at a higher level. That's a joke. I mean, the only thing we have any evidence about is the mental. We're trying to find out what other level relates to this. We look at electrical activity of the brain. We find some correlations. So we assume, okay, whatever's causing electrical activity of the brain seems to relate to this. That might be the neurophysiological. It might not be. I mean, maybe, you know, people like Penrose, who's a not inconsiderable scientist, I might say, one of the best quantum physicists, maybe he's right when he says there are unknown quantum effects that are yielding mental properties. And we got to look for those unknown quantum effects by changing quantum theory. Well, maybe, you know, I mean, that's certainly possible. This particular empirical assertion is just dogmatic. That's why I would block it. This traditional assertion that the mental is properties of matter, matter being whatever there is, I don't think that's dogmatic. That defines naturalism.
No, that is not dogmatic. That is contentless.
It's not
mental is whatever properties of whatever matter, and
that's right.
The economical, the social, the biological.
No, not at all. It's saying it's individualist. It's saying it has nothing to do with social. It's taking an individualist point of view, saying, look, here's an organism. It's got a particular physical object. It's like saying this kind of object has properties of electricity and magnetism. It's not contentless. It's saying if you want to explain electricity and magnetism, don't look for angels. Look at properties of organized matter. That's not contentless. And in fact, that defines the course of science, post-Newton. And the suggestion is, yeah, that's exactly what we should do. It doesn't tell you a lot, that's obvious. It just gives you a course to follow. And the course that it gives you to follow is find the properties, okay, give a theory of the properties, and then search for unification. That is, ask how it relates to other properties. Well, that's exactly the course that I would recommend. Look at the properties that are involved in things like, say, rhyme, or entailment or other formal relations. Try to find those properties, get the best theory you can about them, and then see what you can discover about other ways of looking at the brain that'll relate to this. For example, if you discover that electrical activity relates to it, great. If you discover that there are localization results so that sign and spoken speech are localized in the same place despite the radically different modality, fine. You know, if you have aphasia studies that show that some category of structures is wiped out and you know where the damage is, fine, you've learned more. And proceeding in that way, you try to approach the unification problem. But to make dogmatic claims, no, like you gotta look at the neurophysiological, because I say so, that's pointless. That's what's wrong with this slogan. What should be said, the way it should be said is, I speculate that the neurophysiological is the mental at a lower level. I so speculate. So you notice that this is given as a definition, and it shouldn't. It should be given as, it's got it backwards. It should be given as a speculation, turning it around, saying, okay, we kind of understand the mental. We have computational representational theories which explain a lot of things. I make the speculation that they are expressions of neurophysiology, even though nobody has any evidence for it. Well, that's a plausible speculation. And in fact, it's the kind of speculation which would lead to a research program. It would say, okay, let's try to find what it is in synaptic connections or whatever that have the properties that these guys discover when they look at rhyme or entailment. That's a perfectly reasonable research program. But the way it's presented is just a dogmatic assertion trying to get rid of the sense of uneasiness that some people seem to have about the properties that are called mental. That was my objection. It's quite different from the, it's quite different from either of the other two positions.
Just to the second question that was asked a moment ago about if an alien robot, like the robots on the movies, can understand English or not, I think we have another example. Now we think and we are sure that a robot or a Turing machine that proves theorems really does not understand theorems. So that will be more or less...
Well, how do we know that? I mean, I agree, but it seems to me I agree for trivial reasons, because understanding theorems is a property of people. So therefore, yeah, the Turing machine doesn't understand programs. But, you know, it's true, but kind of, yeah, for exactly Wittgenstein's reasons. And yes, understanding Chinese would do the same. In fact, if somebody asked, does a robot identify a straight line? I would say no, identifying a straight line is something people do. Does a robot take a walk, let's say? I mean, there are robots that move things that look like legs and go somewhere. Suppose somebody said, is the robot taking a walk? It's just a stupid question, you know? I mean, taking a walk is something that people do. If you want to extend the metaphor to robots, okay. It's exactly as stupid as the question whether airplanes really fly. You know? I mean, nobody would waste time on that, you know? And why should you waste time on this? It's the same kind of question.
If you try to push the simulation to the extreme, and then, so suppose you get a human and then just a replication of that human, it still doesn't follow that you have explained anything. I mean, it might be the case that the way you make a copy of a human presupposes that you understand it, you understand how it works. But I mean, it's like if you were to ask Frankenstein how a human works. I mean, it's like, in a way, it's like if you try to synthesize a molecule. Okay, you can do it the usual way. First, understand its structure, then solve the practical problem. But if you do it just by chance or by you don't know how you get at it, I mean, then you haven't explained it.
Well, see, I think there's some issues that have to be sorted out here. Notions like molecule and notions like person are radically different. Now, there's a whole philosophical literature about persons that has to do with things like duplicating them. So this is an effort to explore our intuitive concept of a person. And our intuitive concept of a person is extremely weird. So if you take the science fiction type stories, if a person is, if you look at, some crazy science fiction movie, you get people teletransported, right? They're dropped from the spaceship to Earth instantaneous at the speed of light. And the way it's done is you decode the person's genetic, the instructions in the cells. So you've got a coding of the person, and then you send it at the speed of light to some other place where the person's instantly reconstituted. Well, question, is it the same person? Okay, well, most people seem to think it is. That is, like when kids watch these programs, they say, yeah, the person got teletransported. But then, of course, come the further questions, the obvious ones. Suppose that when you teletransport the person, you leave the original. Okay, you don't eliminate it, you leave it. Which is the person, And if the two are identical, is it moral to destroy one of them? And if so, which one? Well, you get into those questions. Now, and you go on and on. And in fact, if you pursue it, what you discover is that our concept of a person is an extremely weird concept. But that's true of our concept of everything. Our concept of a chair is an extremely weird concept, if you look at it. In fact, the concepts of human language are very strange. I'll talk about this if there's time, either later today or tomorrow. But the concepts of human language are extremely strange concepts. Not human thought are extremely strange concepts. And you got to eliminate them all if you want to do science. They're just not appropriate for science. So you don't care any. Now, molecule, there was a stage when it was sort of like a human concept. But as science marches on, it divests molecule of all intuitive properties. So you can ask questions about identity of molecules. For example, if a quantum physicist tells you that every 2 electrons anywhere in the universe are identical, okay, even if one of them's here and one of them's on Alpha Centauri, well, okay, that means something in quantum physics. Doesn't mean anything in English, But you create concepts which have their own properties, and then you can raise questions about, is this identical with that, or, and you can raise the kind of questions that you've described. I mean, have you understood something if you show how the object, like a molecule, is constructed? You can't really ask that about persons, because persons aren't really objects. I mean, what our concept of a person is something that has a kind of psychic persistence to it. No object in the universe, no physical object in the universe, could have the property that it's over here now, and at the speed of light it's somewhere else, an instant later. That's not a property of a physical object, but it is a property of our concept of person. In fact, there are even simpler things about our concept of person that are strange. Your body undergoes a constant change in its physical substance. Like every 7 years or so, I guess, all the protoplasm is replaced by something else. Okay. Well, if you were looking at physical objects, it would just be a different physical object. If you're looking at it from the point of view of the human concept person, it's the same person. And you look, you look totally different. I mean, you meet somebody you haven't seen for 25 years, they look different. All kind of physical changes have taken place. Is it the same object? Well, you can't, when you're using human concepts, yes, it's the same person, because the criteria for individuating persons are the kind of criteria that you couldn't possibly use in a naturalistic inquiry into the world. I mean, physics isn't going to, or biology is not going to want to have a concept that has these crazy properties. So they're going to have other concepts which they make up to serve the purposes of theoretical understanding. Human concepts are, very limited utility for theoretical understanding. They don't carry it very far, because they got too many weird properties, like psychic persistence, whatever that means, which we sort of know intuitively. And you can do thought experiments in which people tend to agree, although there get to be some where they lose their intuitions, like the teletransportation where you leave the copy behind. That's a point where most people just lose their intuitions. They don't know whether it's the same person or not. So we have these very strange concepts with other funny properties, and those are okay for us. That's the way we get along in the world. But they're no good for science. and therefore to try to draw analogies between constructing a person and constructing a molecule don't make much sense, because there's no notion of constructing a person in the natural sciences, since the concept person can't exist in the natural sciences. It has too many crazy properties.
Yeah.